In this video, I am going to talk about 802.11 frame format. To understand more about 802.11 frames and how they are transported, it might be useful to compare them with the familiar 802.3 or Ethernet frames. Ethernet devices based on the IEEE 802.3 send and receive frames in the format that you can see in the left figure: FCS, data, type, source address, destination address, and also preamble. The sender and the intended recipient of the frame are identified by two MAC addresses, a source and a destination. The source address is not used to deliver the frame. Rather, it is used for any return traffic that is sent back to the source. When the recipient receives a frame that has its own MAC address as the destination, the frame is then accepted and processed. Suppose that the source and destination host are connected by a switch network, as you can see in the right figure. Okay, here the switch that connected to the two hosts forward frame between them as needed, but it does not intervene or actively participate in the exchange. In other words, neither host to be aware of the switch's existence at all. Frames enter and exit a switch simply because hosts are connected to it through wires or cables. The switch silently forwards the frames based on the destination MAC address and the device location it has learned from the source MAC address. Here you can see this frame that we sent from the host 1 to the host 2 has one source address and destination address. Source address equal to the MAC address of the host 1 or the sender. Destination address is the MAC address of the recipient. Okay, and because of that, the switch can forward silently traffic to the host 2, and again in the reverse direction, the source address is the MAC address of the host 2 and destination address is the MAC address of the host 1. Again, the switch can forward the frame from the receive from the host 2 to the host 1. This is the forwarding 802.3 frames in a switched network. In contrast, the APs in an 802.11 network are active participants. You know that from previous videos about the wireless LAN topologies that an AP acts as the central hub or manager of a basic service set or BSS. With the absence of wired connection, a client must join or associate with a specific wireless network by first getting permission from the access point. Then the client must send and receive every frame through the AP or coordinate with the AP for direct client-to-client communication to use 802.11z extension to direct link setup or DLS. Actually, we have a feature, we call it DLS with the IEEE 802.11z amendment that give us the permission to have direct communication between two clients. But in most cases, we use the AP for communication. Actually, the client first sends its traffic to the AP, and after that the AP should forward it to the other clients. But you know that we have a feature, we call it direct link setup or DLS for direct client-to-client communication. About the IEEE 802.11 frame, we can say IEEE 802.11 networks are based on traditional MAC address. Actually, it means that here we use again the MAC address. Each client's radio interface must have a unique MAC address so that frames can be sent from and received to that address. To direct frames through an AP, the AP must also have a MAC address of its own. Wireless client know the AP's address as the BSS identifier or BSSID, which must be included in each frame sent to the AP. This figure shows the basic format of 802.11 frame at the MAC layer, which can carry a maximum payload of 2304 bytes in length. The frame begins with a 2-byte frame control field, as you can see here, frame control field, which identifies such things as the frame time and the direction in which the frame is traveling as it moves from one wireless device to another. I will explain it with more detail. The 802.11n and 802.11ac amendment allows frames to be aggregated and sent as a single unit to reduce overhead and increase throughput. Let me to explain a little about this IEEE 802.11 frame